60 interpolation determinants. Motivation of this paper: challenges. 1. Interpolating randomly missing non-alias traces. This is the easiest scenario. 2. Upsampling spatially alias structural data with regular missing traces. It's the most difficult situation. For example, in narrow rectangular bin without bin scattering, or in salvaging acquisitions in accuracy. What are the determining success factors of 60 interpolation in handling above scenario 2? Apparatus for the tests. They'll use 5D minimum weighted norm, interpolation data fitting by Foley inversion, and 60 AW-MWNI, angular weighted MWNI, where the AW is the sixth dimension containing all dip information. 3 experiments to identify the key success factors of 60 interpolations in handling scenario 2. What is angular weight for dip information? Suppose you have a flat unity reflector in the TX domain. The Fourier transform of it will give you the energy as a vector BIM in the FK domain as indicated in red. If you integrate radially, you will get the angular sum by this equation. And you will see a dot here in the dip domain. A dipping unity reflector in the TX domain will be fully transformed into a slant ray here, where energy will be located. If you integrate it radially, you will get a dot here. You can think of it like a radon transform, and the inverse radon transform will give you an angular weight gamma, a back propagation. 60 AW-MWNI is a combination of AW and 5D MWNI. Suppose you have an observed input data here, D observed. You multiply that with AW, the gamma, you will get an A power I, D sub 0. Feed both into 5D MWNI for data fitting, and then you will get an interpreted complete data D. What if D sub 0, A power I, is very close to the interpolated complete data? Then convergence will be very fast. The yellow here will indicate the switches that we're going to turn on and off to find out the determinant of the 60. Explain. The experiment 1 will turn on the MWI engine and AW off. This will give you the industry 5D. Experiment 2, MWNI engine off, AW on, is the AW sixth dimension action only by equation 1. Experiment 3 with both turn on is the full-blown 60. This is the reference full complete 3D stack and spectrum. This is the control for complex structure conflicting dips. This is the stack of the input 3D decimated gather and spectrum. As you can see in both circles, you see the alias events. This is to simulate coarse megabin for infilling 2/3 empty gathers. How to derive the gamma, the angular weight, from the pre-stacked yield input? This is the input spectrum. You can see alias repeated spectrum. Integrated it radially, you will get the angular sum, and back projection will give you a gamma, which is the angular weight. You multiply this gamma into the input spectrum, you'll get the A power I. Experiment 1, recovery stack by 60 with AW turn off and MWNI turn on. This is the 5D, industry 5D. You can see a pool recovery within the red circle. Experiment 2 with MWNI engine turn off and AW on. This is the action of the AW only, the A power I. It gives a good approximation, a good recovery already, as you can see. This is MWNI only, and this is the AW only. Experiment 3 is a full-blown 60 with MWNI engine on and AW on as well. Will give you the best recovery. Experiment 1, MWNI only. Experiment 2, AW only. experiment 3, full-blown, and this is the reference. Again, this is experiment 1, is a stacked residual of the 60 with AW turn off and with MWNI only. This is the 5D, industry 5D. As you can see, last residual in the red circle. And experiment 2 is the 60 with MWNI turn off and AW on. Will give you the low residuals. Compare experiment 1 and experiment 2. Experiment 3 is a full-blown 60, give you the lowest residual. This is the reference time slides, full-blown, full complete data set. It's a control of a complex event. This is the time slice of 3 to 1 decimated incomplete gather stat, ALIS event. Experiment 1, time slice of 60 with AW turn off, industry 5D. This is will give you the full recovery of the ALIS event, as you can see. Input, output. Experiment 2 is a time slice of 60 with MWNI turn off and AW on, with AW action only, the A power right. It's already give you a good recovery in the ALIS event. Experiment 3 is a time slice of 60 MWNI and AW turn on, full blown. As you can see, experiment 1, 5D only. 2 is the A power right, and very close to experiment 3. This is the reference time slice of the full complete data set. Summary and conclusion. Experiment 1 is the industry 5D by itself, could not recover ALIS data, but recover non-ALIS data very well with good amplitude. Experiment 2 is AW action only, the 6th component. Surprisingly, achieved majority of the best result of the full-blown 60. This is the determinant of 60. Experiment 3 is a full 60, gave the best result in the data recovery of ALIS and non-ALIS data. A good combination is AW to estimate the data, and the MWNI is to refine it. The moral of the story, if you have a good guess of the missing data from the start, you will get a better answer in the end. Thank you.